Hello, Beck. So, welcome to the second lined up talk. We will now discuss IoT trends in manufacturing. So, maybe as you maybe noticed that with the growing number of networked sensors across supply chains, across production plants and product, now the manufacturers are facing a new challenge to come up with a new system that will help them to create a system that in a real time and automatically enables to interaction among machines, systems, things. And this Internet of Things enables actually in manufacturing to create companies or to enable companies to come up with more innovative products and to create synchronized manufacturing. To come up with innovative products, more optimized production. So here I would like to call our speaker, Mr. Oberreiter from CSC, who is the IT strategy consultant and will explain to you more how, what are the trends, IoT trends in manufacturing. So I will give the word to him.
Thank you. Welcome everybody this morning. I'm pleased to be able to on the exciting things. I would like to focus on drivers and case studies and use cases, some use case examples in manufacturing. I'm working as a business strategy consultant at CSC. CSC is a global IT provider, a vendor, global IT provider focusing on business and IT transformation. We are one of the global ones. We are approximately 80,000 employees worldwide. In Austria, we have about 340 employees located in Vienna, in Linz, in Graz, and in Klagenfurt. So, just to introduce the agenda, I would like to start with a discussion of some typical IoT business drivers in manufacturing, and then explain our concept of smart operations, and continue with some use cases and some case studies and technologies, key technologies. The main topics are the advanced predictive analytic technology we have developed for manufacturing applications, and also discuss some use cases for location-based services in manufacturing. Finally, I would like to conclude with a short overview how to get started, how our roadmap to Industry 4.0 enterprise looks like. So, what are the global business trends forcing industrial organizations to operate and compete in new ways? The first one is higher customer expectation and new buying behaviors, like trends for individualization, for sharing, and of course, digitalization in the internet. Other trend is, of course, from the economic point of view, blurring industry lines, which means that competition comes from edges you wouldn't have imagined before. So that industries are competitors not usual until now. Of course, there are also growing regulatory and risk concerns to be considered. And last but not least, hiding demand of increased profitability. It's still the same story, cost pressure and profitability and efficiency. So there are three dimensions we think that organizations must compete in. The first one is customer intimacy. Know your customer, know what the customer is wanting, is expecting, and is demanding. The second one is product leadership. This is all the topic of innovation, of time to market, and driving new state-of-the-art products to the market. And last but not least, it's operational excellence, which means competing on price and on convenience to do business with you. I would like to focus on the last one, on IoT. How can help IoT to drive operational excellence in manufacturing? So if we consider these global trends, we see that manufacturing industries are facing business challenges along the whole value chain. This means starting with engineering, with designing, with creating, with inventing new products, of course also producing them, selling and distributing them to the client, to the customer, and after shipping, also supporting products and customers to drive and to ensure customer convenience and satisfaction. And last but not least, create a global visibility and a global control and synchronize the whole value chain, this whole supply chain from the source to the customer. So examples of such typical business challenges are, for instance, how to include customers to drive innovation to shorten time to market, how to cope with hyper competition, or manage individualization and mass customization to be able to produce highly individualized products in an efficient and economical way. And last but not least, how to create smart products. In the move area, of course, the main topic is to improve accuracy of demand planning, improve agility in the supply chain, and increase the accuracy of demand planning. In support after shipment, a main driver is creating customer convenience, but also create additional business from the service, from the customer service. Of course, last but not least, a major trend is that product developers and product business is changing to service providers. So products become increasingly services. And in the last but not least, it's also important to create a common visibility and a common control on the supply chain. So typical capabilities needed for this challenge, to cope with these challenges, are of course integrating things, equipments, people and business partners, driving collaboration, of course continuously tracking things, assets and operations in the supply chain, and remotely monitor and visualize and control spacious or hazardous environments, for instance. In the support area, a main capability is to use predictive and analytics for preventive maintenance tasks, for instance, analyze product sensor data to improve quality and performance. Think, for instance, of the connected car. And monitor and enhance product function and performance after shipment to improve customer satisfaction. Finally, it's important to respond in real time to external events, to take smart decisions in real time, including environmental events like weather, like traffic jams, for instance, in the supply chain, or some other disruptions and hazards in the supply chain. So this is where the Internet of Things comes in as one of the key technologies we need to provide these capabilities. So the industrial Internet of Things interconnects machines, people, products, and business partners along the whole supply chain. This also includes, of course, suppliers, business partners, and customers, and customer sites. But data alone are not available per se. You need smart and advanced analytic techniques to enable your organization to compete in these 3 dimensions. So if you combine these technologies, Internet of Things connectivity, all over the global connectivity with advanced analytic techniques, you can expect tremendous impacts on your bottom line in operations. Main areas of improvements are, of course, not only efficient operations, efficient processes, but also sustainability, product and service quality, health and safety, equipment reliability and maintenance, and last but not least, supply chain control and efficiency, quality and efficiency. So what is smart operations? We define smart operations as a business capability, enabling you to make sharp and real-time decisions for operational excellence based on a holistic variety of integrated information coming from supply chain, from procurement, from assets in your shop floor, for instance, from product and service quality management, but also from equipment on your shop floor, of course. So we have identified about 6 business functions where smart operations and analytics can be applied to drive benefits. The first one is supply chain and procurement, for instance, reducing inventory or reduce transportation costs by monitoring and by synchronizing your logistic processes. The second one is sustainability. For instance, reduce compliance costs, reduce energy costs you need in your manufacturing processes. Third one is asset optimization. Of course, this is not only a question of utilization, it's also a question of maintenance and of availability. So the main drivers are improvement of utilization and of asset productivity. The fourth one is equipment reliability and maintenance. This means reduction of unplanned maintenance service calls, of breakdowns, of unplanned breakdowns, and of course also reduce cost of spare parts. If you are able to predict availability of your equipment, you are also able to lower your level of spare parts in your spare warehouse. Then we have also the function of product service quality. IoT and analytic also enables you to improve customer satisfaction and reduce costs of rework, of course, if you can improve your quality processes. And last but not least, health and safety, which means tracking your people in a hazardous environment, for instance, and preventing hazards to your workforce, reducing time lost to accidents, and reducing expensive costs for accident claims. So these are the main areas we think that IoT and analytics can help to improve benefits. So let me show some examples of key technologies we have developed for manufacturing companies. The first one is advanced predictive analytics technology. So we have developed for the US Navy flight operations a predictive maintenance solution, a technology which saves the Navy breakdown costs for their aircraft by by preventing and by predicting lifetime and maintenance intervals. So every flight is checked. Before every flight, the aircraft is checked holistically on its condition. So there are many sensors on the aircraft, and they provide real-time data. And this data is analyzed by a predictive maintenance solution, which then reports the safety status and the status of the equipment. So how does this work? So if you consider a helicopter, for instance, there are many sensors in the aircraft. And this data is collected and analyzed and gives you a status which can be classified, for instance, okay, this is a new equipment, everything fine. Or, yes, this is not new, but it's safe. Or, okay, there is some decreased performance. The next step is, okay, there are faulty sensors, there are faulty conditions detected by sensors. And of course, the bad one is there are some anomalous conditions preventing you to start with this equipment. So this is all analyzed in real time, and there are visualizations and reports helping the aircraft workforce to take these decisions. So this is an example of outputs generated by the solution. You see that, for instance, this is an analysis of key landing performance events. So you can see that some important parameters are tracked in a window of good and bad conditions. And last but not least, the system reports the status of the equipment. Another one is the topic of location-based services for smart operations. So if you consider large, spacious environments, for instance, a mining company. One of our customers is the greatest mining company of the world. They have sites over some 200 square kilometers to be managed. And of course, they have a lot of equipment distributed on these sites. And they found out that there is, of course, much automation happened in the past to their equipment. But nevertheless, the workforce productivity decreased over time. So what's the reason? They found out that much time is lost and much productivity is lost by people searching around the site for equipment needed, by lighting towers broken down because the generator is not working, and this kind of stuff. So the main topic was to create visibility, to locate the equipment, and to ensure that it's working when it's needed. And of course also to be able to find it in a very efficient way when it's and observable. The framework shows that there is an environment more or less complex and spacious, and you always have some situations where you have to take some decisions, where you have to locate your equipment, and of course costs are incurred if it's not working. And the solution was to connect all these things to the Internet of Things and create a visual analytic solution to not only to monitor, to identify, but also to control this equipment remotely. So they can turn on and off equipment not needed. They can inspect the status of the generators. They can predict breakdown situations and send maintenance workforce to repair the stuff and this kind of things. And effectively, the company, the mining company, is saving some $2 million per year only by by creating this visibility to their equipment. Okay, another use case is visual risk mapping. It's the same technology, it's the same solution, it's only another use case of it. So what does this do? They are collecting data from private, from public, and from commercial sources, providing environmental risk data like tornadoes, like typhoons, like earthquakes, like travel warnings and this kind of stuff. And they map it to their supply chain, to their planned supply chain transports. And what the system is finally doing, for any transport given, it codes and it measures the impact of these risks, of these global risks, to their supply chain operations. So they are able to redirect operations according to hazards in the environment. And this is also, of course, a very important solution to improve and to manage supply chain risk on a global scale. So what does this mean in practice? We found out that about 50%, about half of the sites of this customer are impacted by hazardous events of one kind of another. So you see that this is a very relevant technology. And we are monitoring all these risks and the impacts to their operations, to their supply chain and global stuff. And this is also important, of course, last but not least, for insurance and for supply chain performance. So this was some use cases and some examples of IoT manufacturing. There are a lot of more, but I just wanted to focus on these ones. And I like to conclude with a statement how to get started. Of course, IoT, Industry 4.0, you can't get it from the shelf. You have to define first your strategy, your roadmap, and of course also your business cases and your use cases. So this is the first very important phase of an Industry 4.0 project, shaping this roadmap. The second phase is, of course, transforming your environment, your IT, and your processes, and realize these use cases. And last but not least, also manage the very, of course, complex environment. This is why also we are providing this kind of technology as a service, so that companies are not forced to make heavy pre-invests to introduce these capabilities, but can use it as a service from the cloud. Thank you very much for your